In this lecture, we will discuss the basic and fundamental concept of network theorem. First of all, we will start with the circuit. So, what is circuit? Circuit is a closed path made of conductor and having circuit components through which current can flow whenever potential difference is created. Okay, so it is a closed path. Let's consider a closed path like this. This one is a closed path having circuit component. So there is a resistor which is a circuit component, and this path definitely it should be made of conducting material or conductor through which current can flow, and current will flow whenever potential difference is created, and that potential difference is created by applying a voltage source. So this is a battery or voltage source, plus minus, this plate is positive and this plate is negative, and the applied voltage is V. So V is the potential difference or voltage which is applied in this circuit. Okay, and there is the resistor as a passive component we have used here, and battery source is an active component. Okay, so later on we will discuss about the passive and active components of circuit. So right now, so this is a passive component or any component that is we have considered in this circuit, and there is a battery source which is applied to create the potential difference in this circuit, and then there will be the current flow from the positive terminal to the negative terminal. Remember that current will always flow from the positive terminal of the battery source to the negative terminal of the battery source. So this is the direction of current flow. Okay, now why current is flowing in this direction? Let's consider a water tank which is situated in upper position, that is number 1 water tank. Then another water tank which is situated in the lower position, that is number 2 water tank. Now if you connect these two with a pipe, then obviously it is clear water starts flowing from the upper side to the lower side. Clear? Similarly, if you apply the potential difference, then what will happen? So electrons are flowing from the negative terminal of the battery source to the positive terminal of the battery source. Thus we can say that this is the direction through which electron will flow from the negative terminal of the battery source to the positive terminal of the battery source, and we will consider the current flow from the positive terminal of the battery source to the negative terminal of the battery source. Thus current flow is nothing but the flow of electrons, but the direction of current flow is just opposite to the direction of the electron flow. So if electrons are flowing in these directions, so obviously current will flow in the opposite directions. Okay, so this is the current direction which is known as actually the conventional current direction. This is also known as conventional current direction. Now the thing is that here we have considered a single loop or single circuit. Now circuit may be like this, having multiple loops. Say there is a voltage source, say it is V1, that's R1 resistance. There is a resistance R2. There is another resistance, say R3. There is another voltage source. Maybe there may be a resistance also. It depends on the circuit. Okay, but we have considered here another voltage source, that is V2. Clear? So now this is a structure which is the combination of two loops or two circuits. So now this is the network. We can consider the structure as a network. Okay, so there may be another loop like this. There is a resistance R4, there is another resistance, say R5. Okay, so on. So in this manner you can increase the number of loops which will form or assemble a structure that will be treated as the network. So this one is a single loop or closed path which is considered as the circuit, and this is the assemble of number of circuits which will give you a structure, huge structure, and that will be treated as network. So that is the basic difference between circuit and network. Now we will see the circuit components. Actually, circuit components are divided into two types mainly. One is active component and another one is passive component. So active components are those components which have the capability to generate power. Okay, like voltage source, like battery source, okay, and current source, so these are considered as active components of the circuits because they can generate power. On the contrary, passive components cannot generate power, like resistor, then inductor, and capacitor. So mainly these three are the passive components which are very frequently used in different type of circuit designing. So among these three, resistor is the power dissipating device. Remember that only resistor is the power dissipating device. It has the capability to dissipate the power. Okay, while these two, inductor and capacitor, these two are considered as power storing device. Power storing. These two are the power storing devices. Okay. Now another topic is very important, that is load resistance. Actually, from the previous circuit or loop, we have seen that if we consider this is a circuit or loop and here we have used a resistance R, okay, and then apply the voltage or potential difference so that current can flow. So that current, let's consider it is I, okay, and there is the resistance. Now the thing is that whenever current is flowing through this resistance, at that time there will be the power dissipation. As resistor is the dissipating device, there will be the power dissipation, okay, across this resistance, and that power P equals to I square R. So this is the power which is dissipated across this resistance. Okay, so whenever this power is dissipated, that means certain level of power is consumed within this resistor. At that time you need to pay the monthly electricity bill to the electricity company. Is that it? That means whenever let's consider the example of home appliances like light, fan, whatever the electrical devices we use in our home. So for this you have to pay monthly electricity bill to the electricity company. Okay, so that is due to the presence of resistance within the devices where power is dissipated. Clear? That means I square R is the power which is dissipated across the resistance which is present within that devices. Okay, and due to this you need to pay to the company. Okay, so thus this type of resistor will be considered as the load resistance. But now very interesting thing is that if you can design all your devices with inductor and capacitor, then you may not pay to the electricity company. Why? Because inductor and capacitors are the energy storing device. They will not dissipate the power or energy, rather they will store the energy and or the power. Okay, so thus if it is possible to design all the devices, home appliances only with the inductor and capacitor, ignoring the resistor, okay, then you may not pay to the electricity company. Okay, but it is not possible. Okay, say if you consider our fan as a load resistance, because if you run the fan, then you have to pay certain amount to the company. Okay, so now in that case we can consider that fan is having huge coil. It's a motor, single phase induction motor that is used in ceiling fan. So I am not interested to go through the details of the single phase induction motor, but you have to, as an engineer, you have to know that single phase induction motor is used within the ceiling fan. Okay, so to design the motor, huge coil is required. So coil means the inductor. Okay, so now you can say that fan is a completely inductor device. Is that it? So coil like this. So this is an inductor. Now we can say that if we use the inductor in the fan, ceiling fan, so there will be no dissipation of energy. Okay, no dissipation of power. So why should we pay bill for this device? The reason is that although the fan coil is inductive in nature, okay, but that inductor is also made of certain conducting material like copper. In generally copper is used. So copper wire is used to form an inductor. Okay, so there is the problem. The reason is that if you use a certain conductor, whatever its dimension, obviously it will have certain physical existence, isn't it? A conductor, say we use this type of conductor, very thin conductor, although it is very thin. Okay, so what? This conductor will have certain length, cross sectional area. So this is the cross sectional area, that is A. This is the length, that is L. Okay, and as we use the copper as a coil, so in that case copper will have its own resistivity, that is known as rho. So we know that R equals to rho L by A. So if any conductor is existing, physical existing is there of any conductor, so obviously this conductor will have its certain level of resistance. So we cannot say that inductor is having resistance 0. Is that clear? And so whenever we will design a coil or inductor for ceiling fan, at that time we cannot ignore the resistance which is available within this coil side. Okay, and due to the huge coil, so length of the coil is also huge. Okay, and due to this the resistance of the coil is also huge. Clear? So that's why although we use the coil or inductor within the motor, but still you have to pay to the company, because there is the availability of I square R loss or I square R power. This power is dissipated across the coil also. Okay, if you can make R equals to 0, then it is somehow it is possible not to pay the company. Clear? But it is not practically possible. Anyway, so this is the concept of the load resistance, where power will be consumed, and due to this you need to pay to the electricity company. So from right now onwards we will consider R as RL. Okay, that is load resistance. So this is load resistance. Another topic which is also important, that is the power which will supply to the circuit, the source. So as a source in this circuit we have used battery source. So actually battery is the DC source. Okay, so power source can be divided into two parts. One is DC, another one is AC. So battery source is a DC part. Okay, DC source. So in this circuit we have used the DC source. So some circuit may require the AC source also. So you need to know the difference between AC and DC. So DC, actually DC is the direct current. Okay, that means there is no change in polarity of the supply. Let's consider this is DC supply and this is time graph. That means time versus DC graph. Okay, so remember that DC will have a constant value, and with respect to time, if you consider this is the time with respect to t, it will be same. Okay, there will be no change in the magnitude of the or polarity of the power source. Okay, so it's a constant. So DC is a constant quantity. With respect to time, there is no change in the polarity or magnitude of the DC. On the contrary, in case of AC, in generally we will consider AC as a sinusoidal waveform. Okay, this is a sinusoidal waveform. That means a positive half cycle, this one is a positive half cycle and this one is a negative half cycle. Okay, so it is AC, and with respect to time its polarity is being changed. That means from 0 to pi, this is the 0 level and this is pi, it is having a positive value, and then pi to 2 pi it's having a negative quantity. Okay, that means 0 to pi it's having positive half cycle, and pi to 2 pi it's having negative half cycle. That means there is the change in the polarity of the supply. Okay, so that means this is the alternating quantity with respect to time. Its polarity and its magnitude are also being changed. That means here it is 0, then it is gradually increasing to the maximum level. That means at 90 degree or pi by 2 degree, it will have the maximum value. Then it is coming to 0. Okay, at this point pi it is coming to 0. Then in the opposite direction, that means in negative direction, it is arriving to the maximum level, negative maximum value at 270 degree. Okay, and then again it comes to 0 at 2 pi. So this is the concept of AC. That means its polarity as well as its magnitudes are being changed with respect to time. Now another interesting thing is that in case of AC we have seen 0 to pi it's having positive side, positive half cycle, and pi to 2 pi it's having negative half cycle. So we know that 2 pi is nothing but 360 degree. Okay, and 0 and 360 degree is same. That means if you consider this, say it is 0, okay, 0 then 90, this one is 90, and this one is pi, 0 degree, so it is 0 degree, 90 degree, it is pi degree, that means 180 degree. Okay, and this is 270 degree, so this one is 270 degree, this is 270 degree. Okay, now we know that 360 degree and 0 degree is the same. That means we can take it from there and put it to here. Okay, that means this, for this positive half cycle we can consider this positive waveform. Okay, and if you take it, that means 362 pi and 0 is the same point. So we will get this 0, or we can say that this is our 360 degree, same point. Okay, 360 degree. Now for the negative half cycle we are getting this waveform. So ultimately what is happening? The thing is that actually we are rotating within a circle. So AC is nothing but the rotation within a circle. Remember that this is the actual interpretation of AC. We are rotating within a circle. Let's consider a globe. If you have a globe, consider a globe. And if you take, say from India, you have take your journey, okay, through this entire globe. Then after rotating, or after completion of your rotation of this globe, again you will come back to India. Okay, so entire world map will be represented within this circle or within this globe. Now if I ask you to represent this globe within this two-dimensional page, then what will happen? So let's consider this is a globe, this is a globe like this. So you can move in this direction and then again you will come back to the same position. But if you are asked to represent this entire globe in a 2D, two-dimensional, then what will happen? You should unfold the entire globe. So that will come like this. Okay, so if you fold this, then there will be the rotation or circle. Okay, and if you unfold this, then it will be like a sinusoidal waveform. So AC is nothing but the rotation within a circle, and if you unfold this circle, then we will get this sinusoidal waveform. This is the actual interpretation of AC supply. Clear?